We're going to go ahead and get started so we don't keep the people that are watching online waiting too long. Again, feel free to get up, get as much food and drinks as you want, restroom. If you need to take a cell phone call or whatever, that's fine too. Just step outside the room. You can walk down the hallway there a little bit and have a little bit of privacy if you need it. So I'd like to start out by welcoming everyone to our kind of a DDC for Dummies class. But it's a basic introduction to DDC Controls. We're not going to try to turn anybody into a control guy in 2 hours or less, but we want to help you understand what to expect from a control system today, what kind of things you can do with a control system, when's a good time to sell a control system, what you can expect to see in the future. So as we go through all of this, we want it to be real casual. Stop me, ask questions all through the class. We'll have some people online asking some questions they can write in, and we'll try to handle their questions at the end. But we'll take your guys' questions as we go through class, and just stop me and let me know if you got any questions, if I'm going too fast, if what I said doesn't make any sense, or whatever. And one of the things that we'd like to be able to do is if your company would like to be able to do some controls, we'd like to be able to help you do that. It's to the point where controls are simple enough today. We can help you through all that. So with that said, we'll get started. If my computer goes. Yeah, actually, that'd be great. Thank you. So, yeah, welcome to the Jackson Systems DDC Basics training class. My name is Joe Jackson. I started my career at a large commercial contractor here in town. I spent about 5 years servicing medium-sized HVAC equipment, low-temperature refrigeration, that sort of thing. After I'd been there for 5 years, I got an opportunity to go to work for the train company, where I got a chance to be a field chiller mechanic. We service large chillers all the way up to about 3,000 tons. And halfway through my career at the train company, they could just see that my aptitude was for controls. With a name like Jackson, it just kind of goes together. So I got the opportunity to go to work as a technician. And eventually, as engineering support, I did all the estimating and also helped with a little bit of sales support. For the last 13 years, I've been here at the family business. Most of you know Jackson Systems as the company who sells zone control, and we manufacture our own zone control. We sell our zone control products worldwide, along with other things like Honeywell thermostats and that sort of thing. But about 13 years ago, Tom and Ron Jackson, my father and brother, could see that there was a need for products that we didn't manufacture here. They were just too complicated for us to manufacture here, and they asked me to join them. I did 13 years ago, and I took several of my fellow employees of the train company. Mr. Dave Moore is now head of engineering for our custom controls group. Dustin Petticourt is head of field operations from the train company. I think Ryan Firebin is also here, who talks to you guys on the telephone when you call in, who's also from the train company. So we have a really, really great group of guys in what we call our custom controls. It's anything you can't buy off the shelf from our wholesale division downstairs. Doesn't matter what the problem is control-wise. Chances are we can help you through it. One of the things that we thought we'd talk about is, when's a DDC system appropriate? You know, if you got 3 rooftops, you can pretty much do that with some Honeywell programmable thermostats. Maybe it's not the right time to use the DDC system. But the time to use a DDC system is when you're trying to differentiate your company from your competitors. So if you got a building that has a whole bunch of rooftop units, and they're trying to manage 45 programmable thermostats, you might be able to differentiate yourself by providing a control system that can monitor and control all that equipment right from right from the owner's PC or even iPad or iPhone if that's what he decides he wants to try to do. So anytime you want to make yourself look a little different, when your customer needs remote access to his building, if he's got an important process and he needs to be able to see that important process from his home, maybe it's a school system and the maintenance guy, every night he goes home and the principal calls him from home and says, hey, you didn't schedule the gymnasium on, we got a basketball game, get back over here and reprogram it. So being able to reprogram the gymnasium schedule from home might be a real advantage. Whenever your customer needs remote alarming, we'll pick on the schools a little bit. If you close your school down for Christmas break, coldest time of the year, if you don't have something to alarm if the boilers go down or a pump goes down or classrooms are below 50 degrees or whatever you want to set your alarms up for, if you didn't have remote alarming, you'd have to have somebody in that school at least go by and check it once a day during Christmas break or something along those lines. Or maybe it's even a more critical process. Maybe it's a manufacturing facility and you need to monitor the boilers to make sure you don't have all your employees standing around waiting for the boilers to go back online. So anytime you need alarming or notification of a problem, a DDC system is a good thing to have. When you need trend data to prove what you're doing, again, we'll pick on the schools. They hear a lot about sick building syndromes, but if we can monitor how much fresh air we're bringing into the building and document that amount of fresh air, when there is a problem, it makes it a little easier on the superintendent or whoever to say, hey, look, we have some sick kids, but we're bringing in the ASHRAE standard of 15 CFM per person, and we can show you how and when that happened. So anytime you need data about what's going on, processes need that a lot too. If you're using a manufacturing facility and you have chilled water and your product's no good unless you got 44-degree water, proving that you're maintaining your water temperature correctly can be real helpful in a manufacturing environment. Improving indoor air quality. A DDC control system can monitor CO2 in the building. It can monitor the amount of fresh air coming into a building. It can monitor IAQ, which is a reading that, kind of a little bit of the building material and glues and drywall and carpeting and all those things, all the stuff that gives off. You can monitor all of those things to prove the indoor air quality in a school or a building. Or maybe it's in a parking garage. We help out with a lot of parking garages these days. If you've got 40 thermostats around the building, chances are after a short time, somebody set one up to run late because they were going to work late and didn't set it back. Nobody's really checking them. So after a period of time, the programmable thermostats, if there's a bunch of them, would tend to not be programmed anymore. It becomes a hassle and nobody's really thinking about it. It might be that you're going to use DDC controls to close the outside air while you're warming the building up in the morning for a morning warm-up period. If you're starting your rooftop unit at 5 in the morning, maybe you don't have to let the fresh air open until people start arriving at 8. All kinds of things you can do energy-wise to conserve energy with DDC that you can't really do with a typical programmable thermostat. If there's a need to tie your building's other functions together, HVAC, fire alarms, lighting, security, all from the same location, and this is becoming a really big deal. You can have your card access system that unlocks your doors if you wanted to. The president of the company can come in and swipe his card, and as he swipes his card to unlock the door, it turns on the hallway lights to his office, and it turns on his office lights, and it turns on the VAV box to his office, and the whole building just kind of comes to life just because the control system in the building knows that he swiped his card at the door, so he's in the building. If you set it up to swipe it on the way out, everything can go back off automatically. And that kind of total building integration is becoming more and more popular. Almost every commercial building today has probably got card access. I know every school does. So it's all coming together. So if it's already all in there, might as well bring it and let it all work together. If you have a very large or very complex system, we're helping a customer down in Nashville, Tennessee. He's got 1,000 tons of chiller, and the problem he has is the facility that it runs, they need cooling all year round. It doesn't matter whether it's 25 or it's 85. They need chilled water. So relatively well, I guess it's a little bit complex. We have a chilled water system that switches over. The towers begin cooling water when it's cool outside. So we're saving a lot of money. We have a lot of big valves to move. Got to shut down some big chillers. So a little bit complicated. But if you have something that's simple like rooftops, if you have 50 rooftops, having a DDC system is a huge help. If you have 50 rooftops in an open warehouse, you probably can't even tell if 10% of them are offline. You have to go up there with gauges and everything else. As you'll see when we take a look here, you can look at the rooftop and say, hey, it shows I got both compressor running. I'm still pumping out 74-degree air. Rooftop number 4 has obviously got a problem. So definitely, if it's large or complex, it's a great reason to have DDC controls in your building. If your customer has multiple sites, another great reason. If he has to manage 15 stores, sure it's great to be able to manage all 15 of those stores from his computer in his office. He can see what time the manager's shutting things down. If he ties his card access in it, he can see what time his manager left. Definitely if you have multiple sites around the city or even around the country, one of the buildings we're going to look at here later just to show you what a typical building might look at today, it's a project we did in Long Beach, California. We'll go live with it tonight and we'll be able to see what's going on. And the biggest reason for it is if you guys want to make some more money. It's a great opportunity. Your competitor is going to be doing it if you're not. So it's just a great way to give your customer what he wants and make a few extra dollars along the way. So we talked about why the building might need it. Here's a few reasons to why we think is good for you. Definitely differentiate yourself if you can truly say you can bring a solution to a customer. That definitely sets you apart. If you can provide remote access that ties together with his operating, especially if it's remote buildings, if you have 3 or 4 or 5 or 15 buildings around town, being able to see when those doors are locked in the building is really nice. Being able to provide trend data for your customer. If your customer's always getting complaints that, hey, my room's too hot, elementary schools or high schools, they're the worst. Teachers complaining, I'm always hot, I'm always cold. But if you can provide trend data to show that person who's complaining, hey, company policy or school policy is we're going to keep the building 74 degrees in the summertime, your room's right at it. Here's the documentation to prove that. Providing diagnostics for very large or very complex systems, just like we talked about with 30 rooftops. You might be able to generate more service work for yourself if you can show your customer which rooftops are running and which are running and which aren't. Or if it's a real complex project with large chillers. Wasting energy because something's wrong in his system. His differential pressure transducers aren't reading anymore, causing his pumps to run at full speed when they don't need to. Definitely you can provide a central location for all their HVAC, fire, and lighting and security. It's a win-win for both you and your customer. And again, it's all about making a few more dollars for yourself and giving your customer a more comfortable, safer, and better operating building. So, how to sell DDC? As part of an energy audit for a customer is a great way. If your customer is concerned about his energy bills, he just keeps asking you, hey, you know, why are my utility bills so high? Anytime a customer asks you that, it's a pretty good sign. He needs a little help with his energy cost. That's a great opportunity to talk to him about DDC controls. When you're replacing equipment is a great time to add DDC controls. I'm not a real big fan of it, but most rooftop manufacturers today, you can buy DDC controls right in them. All you have to do is hook a communication bus to them, pull them back to a little tritium panel or something, and very little cost at above and beyond what you were going to spend anyway to get full DDC controls on equipment as you're replacing it. Same way with chillers. Almost every chiller today is available with the LonWorks or BACnet interface. It's already there. You might as well use it. When you're replacing lighting, if they're doing a lighting upgrade in their building and they're going from some old T12 bulbs to maybe even LCDs, or if they're changing the outside lighting in a building, it's a good time to talk to them about, well, changing the bulbs is great, changing the ballast is great, but maybe we can get them on a schedule to make sure they're shut off. And so they might say, well, you know, my lights come on when it gets dark outside and they shut off in the morning. Well, maybe they need to come on when it gets dark outside and shut off at 9 o'clock because the school's now empty. They can stay off all night and they can come back on at 5 o'clock in the morning when the custodial staff starts to arrive. So all kinds of things you can do with lighting control to save them money, make the building more secure, and lighting, whenever they're changing lighting is a good time to address that. If they're considering installing access control, like I said, almost every building today, definitely every school, is doing something with access control. If they have a lot of employees, if they have a handful of employees, they probably don't have access control. But buildings that have hundreds of people in and out of them every day, they're putting access controls in most large office buildings, definitely all schools. If they're doing that, that's a great time to talk about, hey, you know, we can integrate the access control with the HVAC, lighting, and everything else. As a solution for controlling and monitoring critical processes, I don't know if very many of you guys get an opportunity to do process work. We seem to be involved in more and more of it all the time, where they're doing a manufacturing process and an HVAC contractor is involved because they're generating chilled water, they're generating hot water, and they're pumping that out to their process. And as part of that, you know, the HVAC contractor is involved. So anytime they're controlling process, boilers, chillers, it's a great time. They're going to have something to do it. A sick building syndrome is a great opportunity, especially with a school. If they do have real indoor air quality problems, they have to have a solution. It sure is great to be the guy who comes up with that answer, and a lot of times you can do that with DDC controls, and you can get trends and everything to prove that you've done what they've asked you to do. If it's part of a service contract, if you have a service contract in a building, that's a great way to put yourself in a position to have new controls, especially if you're responsible for monitoring the building or responding to hot or cold calls. It's a nice selling feature if you're trying to get a contract with your customer, if you can say, oh yeah, by the way, we monitor your building off-site. If you call with a problem, we can, before we dispatch a person and run up a bill, we can take a look at unit number 7 and see if it says that it's got both compressors trying to run with and making 74-degree air. Or does it show that it's offline? Maybe you want to have the custodian go check the breakers, make sure the breaker's on. Maybe you can save the customer and yourself some time and money if you have DDC controls that you can monitor from off-site when you have a service contract. Any questions about when or why or how to sell DDC controls? Now I promise we won't talk any more about selling. A little history about, we're going to talk a little bit about the history of controls. We're going to talk a little bit about the state of the industry. We're going to talk about some control system types, some hardware, some software. We're going to talk about what an open system is, why it's important. We'll go live with a couple of sites. Like I said, we'll go to Long Beach, California, look at a building there, and then we'll pick one here locally. So, history of controls. Mechanical controls, which was usually a bimetal type control, came around in the 1620s. And electric or electronic controls came in right around the 1880s. Pneumatics came in, excuse me, pneumatic controls came in around the 1920s. Direct digital, depending on who you believe, DDC came in somewhere around the 1980s. And wireless became part of our world in the 1990s. Anybody got any idea who made the first electric thermostat? Who? No. Well, according to all the document that I found, it was invented by, I'm going to forget his first name, the guy who started Johnson Controls, something Johnson. His first name escaped me. Somewhere around the 1880s. Kind of the state of the industry. This is about what you can expect from a control system today. For the first time, we really are getting to the point where there's true interoperability between equipment suppliers, control suppliers, different brands of controls, different brands of equipment. Truly, in the last few years, it's really it's a real thing. Before that, there was Lawn and BACnet have both been around a while, but there really wasn't a good way to bring it all together. Today we see that more and more, and we'll talk a little bit more about that. But true interoperability between different brands and suppliers and control companies it's a real thing today. Almost all new control systems today are internet-based. You'll be able to run them through a Internet Explorer or Google Chrome or Mozilla or whatever it is that you like. They should really run through a web browser. Now, there's probably going to be a little bit of software from that manufacturer to get the system configured when they originally set it up, and maybe to do some advanced things. But daily operation, you shouldn't have to buy a PC and sit it in the boiler room and buy software and put it on that PC. And then when you say, hey, I want it up in the president's office, he shouldn't have to buy another set of software. And oh, by the way, I want to look at it from home, so you have to buy another set of software. You really shouldn't have to buy any software today. If somebody's telling you have to buy software, that's probably ought to get a second opinion, I guess. Complete building management. Today, again, you can have lighting, HVAC, card access, CCTV. All of that can all come together on one system and can interact. You could actually have a camera that's monitoring a hallway and when it sees motion, it can turn on lights or whatever, turn on the air conditioning, whatever. So all of those things can interact today. And a temperature control system should do what it sounds like it ought to do. It ought to improve temperature control. So a little bit about some control system types. Probably the real leader in control system types today is BACnet. That's probably the one that's going to win. But there's its competitor, LonWorks. And I always explain BACnet and LonWorks to people like this. It's kind of like having a PC that runs Windows and a machine and a Mac over here. They both really do about the same thing, and actually they do them a lot alike. And you know, if you have a Mac machine, it'll run Microsoft Office even though it doesn't have Windows on it. So that's really what the difference between BACnet and Lon is. Distech makes all of their controllers in both BACnet and Lon. They look identical except for this one. This one happens to be Lon, and it's got the little echelon certification here. If it was BACnet, it'd have the BACnet certification here. And the only thing that's different inside is the little communication card, which is this guy right here, and it even says echelon, which is the people who make Lon. You could actually pull this out, stick a BACnet card in there, and it's the same piece of hardware. They, at least for Distech, they program identical. They look and act identical, and there's very, very little difference between the two. So whether you decide to have a LonWorks system or a BACnet system might be dependent on a couple of things. Personally, I've been doing Lon for the 13 years I've been here, and probably 5 years before that at Train we were doing Lon-based controllers. That's the one I like the best. I've been doing it the longest, and it has some real advantages in it. When you put together the communication bus on a Lon controller and the wire runs from unit to unit, it's not polarity sensitive. It doesn't care. If the electrician installs it, screws it up 4 times, you're not even going to know. It'll just keep on running. If you do that with BACnet, somebody's going to spend a lot of time in the ceiling checking all the terminations. Lon is a lot more friendly when it comes to what we call peer-to-peer, meaning if I have 2 of these controllers and I want them to share data, Lon just does that naturally. It's just what it does. You can do it with BACnet if you fight it hard enough. If there's a front-end PC, if there's a tritium panel front-end, then it becomes real easy. But if you're just having 2 pieces of equipment, you want them to share data, Lon does it much cleaner, much faster. It just does a better job. In my opinion, Lon is much more robust. If we hook up a Lon network, when we go to start communicating with stuff, it's just going to work. It just always does. BACnet seems to be a little more temperamental. So because of those reasons, I personally like Lon. But the reality is that BACnet is supported by ASHRAE and probably is going to win in the United States. In the rest of the world, nobody even knows what BACnet is. The rest of the entire world is all Lon. All of Europe, all the Middle East, every place but the United States is almost all Lon. So I don't think Lon is ever going to go away because of the rest of the world. But here in the United States, I think within 10 years, almost all engineers will specify BACnet. Today, it's about 50-50. There's also some other protocols other than LonWorks or BACnet. One of them is called Modbus. Modbus is an industrial protocol. HVAC contractors don't use it much, but for some reason, boiler manufacturers decided that's what they like. So sometimes when you see a boiler, it'll have a Modbus interface to it, and that'll be their only option. Again, we'll talk about this guy, but this little tritium panel, he doesn't really care. He'll do Lon, BACnet, Modbus. It'll do a handful of proprietary control systems as well. It doesn't care for the most part. There's not very many companies doing proprietary controls today. Almost everyone is either LonWorks or BACnet. Some industrial or boiler guys are doing Modbus. But 15 years ago, most things were proprietary. All the Siemens stuff was. Johnson's Metasys, what they called N2, was all proprietary. And so the industry said that's just not fair. there's no value in having a proprietary system, and they force the big contractors, actually the little companies like Distech, force the big guys to start running open protocols like LonWorks or BACnet. And of course there's always the non-DDC stuff, whether that's pneumatic. We don't see a whole lot of pneumatic going in today, with the exception if you have really big valves or really big dampers. If you have 18-inch valves down at Cummins or something like that, it's a whole lot cheaper to buy that valve pneumatic, put what we call an E to P transducer on it. This guy here takes a little 0 to 10 volt signal that would normally move a damper. You put air through it and you run the air up to that valve, and for a whole lot less money you can buy that 18-inch valve with a pneumatic actuator on it than you could with an electronic actuator once the valves get really big. When the valves are small, like this guy here, electronics is even less money, or at least they're close, depending on what it is you're doing. So there's always going to be some pneumatics left for the really big parts, but as the electronic has gotten smarter and less expensive, most of the time pneumatics are either being removed from a building, or they plan on removing them next time they change out some equipment. So, any questions on control system types? Some basic hardware that's in part of every DDC control system. Every system is made up of inputs and outputs. This Distech controller, like I said, it is a LonWorks one. It has 16 inputs and 12 outputs. And there's different kinds of inputs and outputs. Let's just go back here. You can have an input of just about anything you can imagine today. I grabbed a couple of them that we had on our shelf. That's just a long temperature sensor. It's a 10K ohm thermistor. It's 10,000 ohms at 77 degrees. So sometimes it's a little bit mysterious, but you wonder if this thing's working or not. It's really pretty easy. If you go up and you pull the wires off and you hook your ohm meter to it, if you're right around 77 degrees, you're going to see 10,000 ohms. That's inversely proportional, which means as the temperature goes up, the resistance goes down. So you don't even have to have the charts. You can pretty much guess. You know, if you see 12,000 ohms, that's a little under 77 degrees. You can pretty much guess. We hear it all the time. The sensor's out of calibration. Probably not. Thermistors today are extremely accurate. They're extremely stable. I'm not going to say it never happens, but it rarely happens. When somebody calls and tells me their temperature sensor in their room is off, the first thing I'm going to ask is, well, let's see if there's something affected. We see it all the time. Cold air comes down the inside of the wall, pops out through the back of the sensor, and makes it read cold. And then the heat comes on and everyone's unhappy. But thermistors today are very accurate, very reliable, seldom fail, and almost never go out of calibration. So that's just a duct temperature sensor there. This one's an immersion sensor. Happens to have a well screwed onto it. Screw that guy into the pipe. So you can just take your sensor, screw it on, run your wires inside. It's exactly the same. It's 10,000 ohms at 77 degrees. Easy to check, inexpensive. You know, a regular room sensor like this. This one's that one's actually humidity. A room temperature sensor like this guy, you know, it's less than 30 bucks. And you can get them with any flavor you want. This one's just a temperature sensor with an override button on it, but you can get them with a set point. This, we'll kind of switch here a little. Well, step back here. This is an averaging temperature sensor. It belongs in the mixed air. I think this one's 22 foot long, so it's designed to serpentine across the outside and return air where they come together, so you can get an average of that. Because sometimes if you just put one of these guys in, if it's up where the outside air is, it's going to read cold all the time when you open the damper in the winter time, and it may not be a true reflection of what's coming through the air handler, where an averaging sensor will fix that for you. If you're going to add some controls to a boiler or chiller system and and it's not in the budget to go back and add wells. We make some strap-on temperature sensors. If you clean the pipe real good and you put a little thermal conductive paste on there and you clamp this guy down nice and tight, it'll be almost as accurate as this guy. But if you don't clean the and having a welder come in and put you some threadlets in. So this guy here that looks just like the temperature sensor actually happens to be a temperature and humidity sensor. So if you were going to put that in an office space, you could measure the temperature and the humidity from one device. This happens to be a freestat. It's a little different than this guy, because this guy finds the average. This guy finds the coldest spot. And so since it's protecting your hot water or chilled water coil, anytime the air temperature gets down below 38 and you're nearing freezing, you want to shut the dampers, open the hot water valve, stop the fan. So this guy finds the coldest spot. That's about all the temperatures we got. This one happens to be a CO2 sensor for measuring CO2 in a room. Duct pressure transducer, just a pressure switch, and a current transducer. And finally, carbon monoxide transducer for like a parking garage. So as you can see, there's just about a sensor to read anything you can imagine. Temperature, dew point, enthalpy, or you could figure enthalpy based on a temperature and humidity sensor, put them together. The controller actually has a little block that will calculate that, do that math for you. Gas detection, the gas might be CO2, it might be refrigerant, it might be carbon monoxide, whatever the gas is, you can detect it. I didn't bring one in, but there's light detection, so that if you have a big atrium in a building and the sun's out, you can detect the light level in the room, either shut off or dim the lights in the room. So there's just about every kind of sensor you could imagine they make. They're relatively inexpensive for the most part. The gas detection stuff is probably the most expensive, but temperature sensors are very inexpensive. CO2 is not too bad. So whatever it is you need to sense, it's not a problem. And all of these sensors come in two basic types. They have analog sensors, which is what this guy is. It's a resistance. It changes all up and down. Where this guy here is a digital input. It's just on or off. If it drops below 38 degrees, it opens a set of contacts in there. That's the end of it. That's all it does. It's just either on or off. So we would call that digital or binary. And we would call a temperature sensor or a humidity sensor or a pressure sensor or a current sensor. That's an analog. It's a varying value. This happens to be a pressure switch. It's an on-off. And so all of the inputs in this controller, they don't really care what kind of sensor it is, but we have to tell it what it is. It can do like the humidity sensor here, it's a 0 to 10 volt signal. The temperature sensor, it's a resistance. A pressure switch, it's just a contact closure, or a freestat, it's a contact closure. So it doesn't care what kind of signal you give it within reason. It'll do 0 to 10, it'll do 4 to 20 milliamps, it'll do a contact closure, it'll do a thermistor, it'll do a half a dozen different thermistors. And if you are able to find a sensor that it doesn't understand, it actually has a little table in there. You can build your own range for the sensor. So if you had something that was reading, I don't know, what's something we don't normally read, Dave? Well, if you did come up with something that wasn't standard, if it was so off the wall, some industrial process or whatever, if you could come up with it and it puts it out, we can probably set this guy up to read it. But most of the time it's either 0 to 10, 4 to 20 milliamps, 0 to 10 volts, 4 to 20 milliamps, a resistance, or a contact closure. Those are the main kind. So any questions about inputs to controllers? There's also outputs. That's one half of this controller is the input. which is this guy down here, 16 different inputs. Yep, sure.
Go back to your input. You can use any input on any input, and your controller's not designated analog and digital.
Great question. No, it's not. They call some control, especially older controllers. I'll pick on the train company a little bit. Their standard controller that they used for a long, long time had 6 analog inputs and 4 digital inputs, and that's the way you had to set them up. This is considered universal. It doesn't care. You can have any sensor on any input. It doesn't binary, analog. It doesn't care. You tell it it's analog or digital. And I don't know if anybody cares, but the way it really works is this little controller puts out 5 volts DC. If you tell it it's a digital, it's just looking for that 5 volts to come back on the other wire. If it comes back on the other wire, it knows the contact's closed. If you tell it it's a thermistor, it puts the 5 volts out through the thermistor, and by how much of that voltage comes back, it can calculate what the resistance is, and therefore it can calculate what the temperature is. So this guy just puts out 5 volts DC. There's nothing spooky about it. If you had any questions about whether the input was still good, you could actually stick a DC voltmeter on there to see if the 5 volts is there. That would give you an indication whether it was a problem or not. Does that answer that one? And actually, the outputs are the same way today. The way Distech has decided to do it so that they didn't have to have some digital input, or excuse me, some digital outputs and some analog outputs. They decided to make all of their, on the basic controller, all of their outputs, they call them universal. And what they do is they put out 0 to 10 volts, they'll put out 4 to 20 milliamps, or if you want to turn something on and off, it puts out 12 volts DC, and we pull in a 12 volt DC relay. So I can take any output and set it up to control my damper actuator at 0 to 10. Actually, Blemo uses 2 to 10. Or a Blemo valve, also 2 to 10. 2 to 10 volts DC. Or if you want to drive a pneumatic valve, you could send that 2 to 10 or the 4 to 20 to this guy, and he could regulate pressure. But if you were just going to turn on and off a compressor, you would run it the 12 volts out. You tell this guy, tell it it's a digital output, and it'll turn on or off the 12 volts DC to turn on or off the relay. Now they actually do make a version that's nice for rooftops and things like that, where they're not universal outputs on the first 5, so that you can do 2 stages of heat, 2 stages of cooling, and a fan with a dry contact. You don't have to use a relay. But the standard controller, where we're doing a chill water plant or a boiler or big complex air handler, most of the outputs are analog anyway, with the exception of starting the fan or something. Even the speed of the fan is still a 0 to 10 or 4 to 20 milliamps, so it works out really, really well. And then, like I said, if you've got a small rooftop or something like that, they do make a version that's got the first 5 outputs as just contact closures.
Does it require a resistor then if you are distinguishing between 4 to 20?
It's actually built into the controller.
Okay, so you don't have to add.
You do not have to add a resistor anymore. You used to have to do that. It's actually got a little set of jumpers here on the outputs. If you're going to do 4 to 20 milliamps, you move the jumper to the I think it has an I, because current starts with I. And if you're going to use it as a 0 to 10 or a digital, you leave it the other way. So here at Jackson Systems, we're not a real big fan of anything that's 4 to 20. There's nothing wrong with it, and it has some advantages. But 0 to 10, it's nice to be able to just walk up and put your meter on it, 0 to 10. If I want to check to see if this valve's working, and it's this guy happens to be 2 to 10, so at 2 volts it's closed, at 10 volts it's open, at somewhere around 6 volts it's half open, and you just put your meter on there and measure it. That's all there is to it. But if you do 4 to 20, you have to take one wire off, you have to move your leads, you have to get into the middle of the circuit, and the circuit doesn't work until your meter's hooked back up. So unless there's a special reason, we just do 0 to 10. It's just so much easier. Now on the other hand, if you had to control a valve and the controller was in the boiler room, and it was a bypass valve to maintain loop pressure, and it was going to be at the other end of the building, you'd probably have to use 4 to 20 because there'd be some voltage losses in a wire that long. And the 4 to 20, it doesn't care about voltage. It just keeps cranking the voltage up till it gets the current where it wants to be. So if you have really long runs, 4 to 20 is better. If you have an input,
What's really long run? Is that 300 feet?
yes, 500 feet, 300 feet, so just halfway across the high school or something, there is some advantage. If you had inputs that are 0 to 10, they're a little bit susceptible to electrical noise because it can just jump onto the wire. We don't have any trouble with it, but if you were going to run a wire, I don't know, 1,000 feet, and it was going to run parallel to a bunch of 480 volt wires, it probably wouldn't like that. You'd probably make that sensor 4 to 20 milliamps, and it wouldn't pick up any electrical noise. I can't remember ever having to do that. I did have to do the pressure transducer. We had to do it in 4 to 20 because it was just so far away. And most of the time, if we need to do that, we would just tie into a controller on the other end of the building where the sensor is going to be and pass the information across the network. So we didn't have to do that 4 to 20 or really long wire run. So 4 to 20 does have some advantages. You might, if you were doing some industrial process, they may not have 0 to 10 as an option. They may just it's always 4 to 20. Dave had us doing one the other day, and the customer had 4 to 20 already on their system, and they wanted us to split it and try to share with them, and it just didn't work out. There's some other things about 4 to 20. Some 4 to 20 is what they call syncing, and some 4 to 20 is what they call sourcing, which means where does the voltage come from. So in general, 0 to 10 is a whole lot better unless there's a special need, and either way we could help you sort that out if you needed to. And that goes for both inputs and outputs. And wireless. We see more and more wireless every day, and it's really what people ask for day in and day out, probably without really even knowing why. They're used to Wi-Fi at home, and so they think having a wireless temperature sensor in a room is a great idea. Maybe it is. Our philosophy on wireless is we don't do it unless there's a reason. All of the Distech controllers, whether it's a VAV box controller or even this guy here, has a little port right here where you can plug a wireless card into it. And it'll talk to all kinds of wireless devices. Room temperature sensors, humidity, duct, whatever you want. You can hook a wireless light switch up to it. Just about anything you can figure out this way, you can probably do wireless to this device. And each one, depending on the size of the device, can handle I think it's like 8 wireless devices. But you think, well, maybe that's going to save me some money because I don't have to pull a wire. Probably not. A $30 room temperature sensor that you have to pull a wire to, goes to $100 if you have to do it wirelessly. So in general, we haven't found a whole lot of reason to do it. The other reason is if you're wondering if this thing's working, you pull the wires off, you stick your ohm meter on, 10,000 ohms at 77 degrees. You know instantly whether it's good or bad. And you can check the wire. You can leave the wires hooked up there and pull them off at the controller, and you can measure the wire and the sensor. Instantaneously, you know what's going on. You can be confident about your diagnosis. But if the wireless temperature sensor stops working, why? Is it a bad sensor? Is it a bad wireless card in here? Is it too far away? Is there too much concrete or steel in between them? It just doesn't make a lot of sense. On the other hand, if they ask us to stick a temperature sensor in the middle of a granite wall that they spent $50,000 to put in, and I don't want to drill into it, let's get a wireless sensor and some double back tape and stick him on there. Yes, Mr. Fisher.
Train is touting all the wireless technology, and Johnson Controls now has a replacement pneumatic step that snaps right in place.
Mm-hmm.
And my concern is from a security standpoint, what's the penetrability of that from an outside source?
Probably very, very little. Most of that stuff is 900 megahertz, so it's on the same frequency as your home wireless phone, not your cell phone, but a wireless phone. And there's just not it's not it's not a frequency your laptop talks on. It's not the same protocol. I don't have any concerns about wireless. I know that the Trane wireless stuff has been really successful in the last few years. Trane's had wireless out for probably 25 years. We did the first wireless VAV system at Trane at Ball State University as a beta test site. In my early years, it has to be at least 23 years ago Trane started doing wireless. So they've had a long run at it. At the same time, when we were at the Trane company, they had wireless thermostats on the wall, and once a week I would get, if I was in the office, I would get a phone call from somebody saying, hey, my office is uncomfortable, can you check into it? And we had an office maintenance person, and I said, well, can you have the maintenance guy check the batteries? And they said, well, he's not around. Well, the control system could see the battery strength, so we'd look at it online from my desk, and yeah, your batteries are dead. And we tried to get the maintenance people to change the batteries every January. The batteries were rated for 2 years, and they usually lasted a little over a year. But we said, if you change the batteries every January, it's probably going to be okay. But it's just something else to maintain. And as we go a little further, we'll see about what Distech, what their feelings are about wireless and where they're going and where we see everyone else going. There is some reasons to do wireless, but we don't believe doing wireless just to do wireless is a good choice. Maybe someday it will be, but so far my experience, both here and at Trane, says it does work, but when it quits, let's put it this way. How many people in this room feel they could troubleshoot a Trane wireless system? Not me. I know I can't. That means nobody except for Trane can service that system. And we'll talk about why that's such an awful choice for your customer, to have a system that only one company can service. But wireless is legitimate. It's coming stronger and stronger. It's getting better and better. And it's definitely what everyone says they want. Controllers. There's a couple of different types of controllers. This guy right here is a VAV box controller. When it's installed, it looks a little bit like that. It has a couple of pressure tubes to pick up the airflow in the duct. It has a place to hook a wireless card to it. It has a place to put inputs and outputs, like a duct temperature sensor if you want to know what the temperature coming down the duct is, or downstream if your VAV box has a heater, you want to know what the temperature of the air coming off the heater is. It can read temperature, it can read humidity. It has an input that you can set up as a door switch, so if it's in a classroom and somebody goes and opens the window, it shuts off the air conditioning. Does sense in running the air conditioning if they got the windows open. So it's a VAV box controller. That's all it does. That's all it'll ever do. It does a great job. But it has a set of ways to do what it does, and that's all it does. You can't change it into a rooftop controller. It just won't do it. But it's inexpensive. It's real easy to set up. We'll actually set one of these guys up together. After you've done 2 or 3 of them, you can set one up and get it programmed in about a minute and a half. They're really reliable. This guy happens to have a Belimo damper actuator built right onto it, and a little Distech controller inside. So configurable controllers are less money. They're easier to set up. They're easier to troubleshoot, but they're not very flexible. If you've got a real challenge in your building and you need to do some special things that are out of the ordinary, configurable is not what you'd want to use. You'd want to use a programmable controller. And Distech makes this same controller in programmable. So if you wanted to do something that's beyond normal for a VAV box, I don't know what that would be exactly, but if you did want it to do something abnormal, you could use a programmable version. I guess the only thing I could think of, we did a project in downtown Columbus called the Columbus Commons building. It's a 5-story, 6-story office building down there. And as we were finishing up the job, they were looking to get some extra lead points. And they wanted to take the fan inside the VAV box, which normally runs at full speed and maintains constant airflow, even though the damper's open and closing. They wanted to make that variable speed. I'd never heard of anything like that. And as it turns out, they decided not to do it. But we talked about using a programmable version, one of these, so that we could vary the speed of a fan in a VAV box. Just not something you normally do. And ultimately, they decided not to do it because while it wasn't a real big deal to switch over to programmable controllers, it was a really big deal to put variable speed fans inside of VAV boxes that were already installed. So if you do have something special, VAV boxes can be either configurable or programmable. Almost always we use a configurable one. A lot better value because they cost less and they cost less to get set up. But the programmable controllers, which is what this guy is, can do anything you want it to do within the limitations of the equipment it's controlling. The programming is relatively easy to use. If we spent 2 hours together and you had just a little bit of practice after that, anybody in this room could write programs and put them in this. The hard part about this is understanding what the equipment really needs to do. Like at that big chilled water plant we're doing in Nashville, Tennessee, the programming isn't very complicated, but you really have to understand primary, secondary pumping on a chilled water system and what happens to a York chiller if you let water flow through the York chiller when it's not on. I can tell you that water flows through the cooling ports up to the variable frequency drive and it sweats. And now your 500-ton chiller's got a real serious problem because it's got water hanging off its variable frequency drive. So understanding what the equipment's really supposed to do is definitely the hard part. Programming is not the hard part. Brought up a picture of a damper actuator. Don't know why. I think the slide's a little out of whack. That's actually a picture of a strap-on wireless pipe temperature sensor. Great idea if you want to put a pipe temperature sensor up in the ceiling. And most of these temperature sensors, they actually get their power from light. So when you put it up in the ceiling and close the ceiling up and the light goes away, your sensor stops reading. That's a configurable VAV controller, programmable one. The one on this slide, they make them a couple different ways. These are handoff auto switches, so you can override things if you'd like to. The one that we've got here actually has a little LCD screen. It doesn't look like much from there, but it's actually really, really cool. You can override every single point in the controller. At a glance, it tells you what's overridden. It tells you if any of the sensors fail. It's all super easy to use, super friendly. It's really, really a nice feature. It costs an extra $100 to throw it on a controller, but well worth the $100. The other good thing is if you're doing a project, and let's say that you're not going to put a full front end on the job, but you have a process. Actually, Joe and I are doing one together where they have a 2-pipe chill water, hot water system. And as the weather changes, we have to switch between chill water and hot water. And the air handler has to know whether we're delivering hot water or chill water. The project's on a fairly tight budget, so we're going to stick one of these guys on each air handler plus one of them down in the main plant to switch over. And they're not going to have a front end, but all of the information about the system, what it's doing, what it's thinking, is going to show up here. And like I said, it's just really, really user-friendly to have on your equipment. We mentioned that programming today is relatively simple. I'm an air conditioning guy. I'm not a computer guy. My father, Ron, myself, and now my son, Ryan, works here. My son, Ryan, is a computer guy. He can write programs, brings them around me. He's only been doing it for 5 years. But at the same time, the hard part about what we do is not the programming. It's understanding the mechanical systems. That's why it's a whole lot easier to take an HVAC guy and turn him into a control guy than it'll ever be to take a computer guy and turn him into a control guy. The computer stuff is getting easier and easier every day, and a good HVAC guy that understands what's supposed to be going on in the building will always do a better job than a guy who's just a programmer, who's convinced if he writes a program, the building will function correctly, because that's just not the reality. So for the most part, there's two kinds of programming in our industry. One of them I'll call basic. It's based on the basic programming language. and we'll see what that looks like. And then there's a graphical program, which almost everyone has gone to. And like I said, if we spent 2 hours together, there's no one in this room who couldn't write a relatively sophisticated program to do whatever it is they wanted to do. It's just that easy. It takes a little bit of practice, but not too bad. So this would be line by line or basic programming. You know, it's got a lot of ifs, elses. You define terms. It says if the occupancy equals 0, which happens to be occupied, then the unit mode equals 0. Then you can just see that just even reading that can be tough. It's tough for me to read it, and I wrote it. We haven't used this kind of programming in almost 5 years. But this is just a little bit of programming to check to see if the unit's occupied and to see if which set of set points we're going to use, whether we're going to use a heating set point or cooling set point. So not very friendly. There's a few manufacturers of control products today that still use this, not very many. Most of the time, it looks like this. That probably even looks worse. Maybe it's not even a very good example. But this is a very, very sophisticated program, and you can see it's just a matter of drawing lines. And if you understood what these little blocks do and how they work, you would find that you can write a simple program. And we'll actually do a little bit of this here in a minute, so you get a little better feel for how that works. But definitely, you should expect a control system today to use block programming or graphical programming because it is significantly easier. And like I said, we'll do a little bit of that here in just a little bit. We want to talk about open systems. In our opinion, open systems is the most important thing about a control system. What does all that mean? What does it take to make a control system open? Well, in our opinion, it takes a couple of things. It has to use one of the two open protocols, either LonWorks or BACnet. Like I said, I personally like LonWorks. I think it's a more stable product. It has a lot of advantages, but I think the industry is going to go BACnet. So one of those two is important. You have to have a product you can buy from multiple vendors. If you buy a train tracer system, it's a good product. It really is. It's all I did for 15 years. And I did programming sitting in front of the TV at home. It was great. But if your train system doesn't work, if your train wireless system, even worse, doesn't work, what are you going to do? You're going to go to Train. That's the only option. And Train's a decent company. But if you'd like to get a competitive bid on getting that system fixed, there's no competitive bid. You might call Jackson Systems. They got a couple of guys around here that know a little bit about it. We might be able to help you. But if you have a Johnson Medicine system in your building and they're going to add on to it, what are you going to do? You're going to call Johnson Medicine or Johnson Controls, and they know they've got you. And I'm not beating up on Johnson any worse than anybody else, but let's face it, the price is going way up if they think you're the only source. That's just a fact. And a lot of companies, not just Johnson, a lot of companies do that. So if you have an open system, then at least you can go get competitive bids. And even if you decide to give it to Johnson Control, we do this all the time. Customer calls and says, hey, I've got this X brand of system, and I need, let's say it's automated logic. Let's say it's Allerton. Allerton uses the same Tritium front end that we use. It's all BACnet. But if Allerton doesn't think they have any competition, their price is going through the roof. If we just offer to bid the job, if the engineer just lists a second person as an acceptable bidder on that job, their price plummets. They still probably have an advantage. They know the building. They set the software up. We'll probably fight with them a little while to get the password out of them. But just being in the bid, because it's an open system, saves your customer an unbelievable amount of money. It's just unbelievable what it does in having competition. It's the way the United States was designed to work. It's all about competition. It's all about keeping somebody honest. So having an open system keeps your customer in a position where at least their vendors know there's another option. You need an option for where you can get service. You need an option for where you can get parts. You need an option for who you can call to get it expanded. All of those things. You need an option about where you can go to get software. You need an option about where you can go to get training. All of those things are really, really important. Now, if you're just putting a small office building together with 4 rooftops, maybe it's not that big a deal. But if it's in a school system where you know they're going to be adding on to it eventually, and you know it's long-term and that they're going to need service, it's truly important to your customer to provide an open system. And there's a lot of people who do that. And there's a lot of people who kind of do that, maybe not so open. And I'm going to pick on Train a little bit just because that's my background. A Train Tracer system, Tracer Summit system, it's a great product. It's a great product because it was designed by air conditioning people for air conditioning people. And it's BACnet. It's an open protocol, but it's not open. You cannot get Train Tracer Summit software from any place but Train, and it's really expensive. And if you need help installing it, you have to have a Train service tech do it. You have to have a Train service tech license it. You can't even license it yourself, and you have to pay that. It is not an open system, even though it runs on an open protocol. If you pick a system that uses Tritium, we'll stop and talk about Tritium a little bit. Tritium is technically owned by the Honeywell Corporation. The strength of Tritium is everyone offers it. If you ask Johnson Control about Tritium, they'll say, and they'll whine and complain a little bit. They'll say, no, Johnson Medisys, Johnson Medisys. But if you push them hard enough, they'll say, okay, Tritium. They have it. They call it Johnson Building Explorer. If you push Train to use an open front end, don't use Tracer Summit, use Tritium. They'll whine and complain and tell you how great Tracer Summit is and tell you why they should use it, but it's not open. They have it. They call it Link Springs. If you go to Allerton, Allerton has their own front end, but if you tell them you want Tritium, they'll whine and complain, and eventually they'll agree to put in Tritium. And when they do that, when they use a Tritium front end with an open protocol like LonWorks or BACnet, now you have hardware that you can get from Distech, Johnson Controls, Siemens. It doesn't matter. You can buy it anywhere. You can buy it off the internet. And in Indianapolis, there's probably 15 companies in Indianapolis that can program a Tritium box. It's a little bit complicated. It's a little bit complicated because it's everything to everyone. It can do LonWorks, BACnet, Modbus, Johnson's N2. It can do a handful of proprietary things. So it's got a lot of extra junk in it that you don't need. But there are a lot of guys who can program this device, and it gets easier and easier every year. And there's a whole community of people online that support this. My son is great at it. If he's got a problem with Tritium and he doesn't know the answer, in 15 minutes he's on the Tritium website sending out a question, and there's 15 guys who want to be the hero and answer it for him. It's just unbelievable, the community that built around this product. So this product makes every system open. It costs less than a Tracer Summit panel. And you can do 99.9% of everything you want to do on it through Internet Explorer or Google Chrome. So you don't have to buy any software. You've got lots of choices where to buy it. You've got lots of choices where to get it serviced. It's what really makes a building open. So just because you have a system that runs LonWorks or BACnet, like a Tracer Summit system, doesn't make it open and doesn't do any justice to your customer unless your customer just really likes Train and plans on liking them forever. I can't imagine how many building owners there are out there, and Joe and I just had a conversation about how much they hate Johnson Controls. Well, a lot of people laugh at that one. And Johnson Controls isn't an evil company. It's just that they know once they have their Johnson Medisys system in their building, you have one choice. Two choices. You can tear it out and start over, or you can call Johnson Controls and pay their $120 an hour or whatever it is they charge and wait the 2 weeks or whatever it takes to get out there. So having an open system, in my opinion, is the most important part of having a DDC control system and what you use to make your selection. And I think it's the most important thing to your customer. I'll tell you what, we're going to take a short 5-minute break, let everyone use the restroom, get some more to eat, get something to drink, and then we'll jump back in and we'll program a VAV box. Oh, good. Oh, great. No, the Novar stuff, they tend to be mostly on top of Walmarts. Um, and the CPC, that's the refrigeration stuff, right? Yeah, no, we don't. Now, for the most part, we support our controls. We support Train Tracer Summit. Um, we'll support a product called American Automatrix and a product called Solidyne. And on occasion Honeywell. We don't have access to the Honeywell product line, so we tend to shy away from it a little bit. Um, but in general, we don't attempt to try to service a lot of other people's controls. Yeah, I told them we were going to take 5 minutes. They could hit the restroom and grab some more food and drink. And yeah, I'm going to run through the software real quick and be done here in less than 30 minutes. At least that's the plan. one time and tweak it a little bit, because one of the ways. Well, let me say it dropped from 70 to 60 or something. It changed 10 degrees ish at night. So one of the things I made it really accurate was I limited how much of the heat was ever allowed to come on. So if it decided that somebody opened a door or something, it couldn't go rampant electric heat wide open. So it really came on slow, and I think I stopped it at 60% capacity, and I had to run that up to let it go to like 70% capacity. As soon as I did that, went right back to 0.2 degrees plus or minus, and haven't heard about it since. So they got sensors that are on a pole that they got one here and one here and one here and one here, but it dialed it right in. Yeah. Oh yeah, it was definitely a misapplication. I think our thing was like $4 grand. I don't know what they spent on the valve and all their time and everything else. Yeah, that was a day. They probably had 10 grand straightening it out though. Yeah. Yeah, that was definitely a misapplication. That is it's owned by Siemens, and it's called Stafa. There you go. That's a good product. They use tritium. It's all BACnet. Scott Grantham owns it now. Lanus and Gear owns.
Layers and layers and layers of distribution. Oh, I see what you shipped. I sent you the email.
Yeah,
That's all right.
they got it earlier today.
That's fine.
Sorry
That's
about
all right.
that. You'll get it tomorrow.
Yeah.
Yeah, I know.
Yeah, that's all right.
Nothing like what we run up here.
So you guys, the VAV controllers, are they similar to Krieger's? Are they make them for you or something?
KMC? No, they don't make them. Well,
Actually, the Simply VAV is actually made by KMC. Yeah.
Is this what you got? Is it similar to that? Or?
Yeah, very, very, very similar.
Similar, but it's not the same product. Matter of fact, they probably use the same enclosure, but KMC makes its own controllers and probably still uses the blue line.
I just put one of them in there. That's the first one I ever put in.
They're really nice.
Mm-hmm. Yes.
Yep, that's actually made by KMC.
Mm-hmm.
All right, we'll go ahead and get started again just so we can get everyone out of here at a reasonable time. And what I thought would be the easiest for everybody, maybe not everyone in the room is necessarily familiar with how a VAV box works and what to expect out of it, but definitely everyone here is used to a rooftop unit. So while this is a VAV box configurable controller, they also make one for rooftop units, fan coil units, classroom unit ventilators, rooftops, fan coil, and heat pumps. and they look like this. They don't have the display on them, but they're shaped like that. And they just have inputs and outputs, and they're really easy to use. Like I said, they're inexpensive, but definitely the reason for using them, the reason we use them still, is because they're super fast to set up. They're super easy. Mechanical contractors that aren't necessarily familiar with it won't have any trouble with it, and the owners won't even have any trouble with how it all works. So all you do is just decide what it is you want to do. So we'll start out with some inputs. What's one input that you would think every rooftop controller would have to have on it? A fan input? Fan status, okay. Wouldn't have to have a fan status, but we put a fan status on almost every rooftop. We come down through here, and here's all my choices. Fan state. And it asks me a question if I want to set it up to the default, and I just say yes, and it's done. So this input is designed to have a little current sensing donut hung across the fan coil, fan wire, and when the fan current starts drawing, it catches it and tells us that the fan is running. Unfortunately, if it's got a belt on it, it may or may not tell you the belt's broke. So the status of the fan is definitely one choice. What else does every other rooftop have to have? Temperature, room temperature. Actually, that next one I missed. Space temperature. So we could grab one of these little $30 sensors. They're available with lots of options. This one has an override button. You could get it with a set point. Maybe you don't want them to be able to adjust it. Maybe you only want to do that through the computer. So we're going to have a fan status and a space temperature. What would be a really good thing to have on a rooftop? Discharge air. That's a really important one. Now we don't have to go to the rooftop to see if the thing's actually working or not. It's all about making life simple. I would say those are the three big things we'd always have on almost every rooftop. But there are some other options we could throw on there. And we'll just go down through here real quick and let's take a look at what our options are. Maybe you want the return temperature so you could quickly tell what the delta T is across the rooftop to see how well it's running. Supply temp we already got. Maybe you want the outside air temperature. Maybe, maybe not. Rooftop units, we typically wouldn't have a mixed air temperature sensor like this guy. But this same controller will also do a nice job for a simple air handler. We probably, if it was an air handler with water, hot and cold water, maybe you want a water temperature sensor. Not typical for a rooftop though, but maybe space humidity. So we'll throw a space humidity sensor on there and it'll auto set it for us. Configures the whole thing. But they make different kinds of humidity sensors, so let's see what it did. So it set it up as linear, and it set it up as 0 to 10, and it's going to, at 0 volts, excuse me, at 10 volts, it's going to read 100%, and at 0 volts, it's going to read 0%. That's typical. Nothing spooky going on there. If we were actually connected to a controller, which we're not, you could click this button and it would tell you what the current value of that sensor is. But if the humidity sensor was only read between, let's say it read between 20% and 80%, which is not unusual. It's not what we do, but if the humidity sensor could only read in that range, you could set it up for something different if you wanted. And just click OK, and it puts it in there. So see what else we might want. CO2 levels. Be a good thing to have on a rooftop today. Again, we can let it do its own thing, but a standard CO2 sensor, at least the ones we sell, are 0 to 2,000 parts per million. Most of the time in a classroom or something, you want to keep it down around 1,000 parts per million, so right in the middle of the range. We got these rooftop controllers have 6 inputs, so we could throw one last thing on here. See what else there is. If it was if you wanted to watch the duct pressure, you could. If it was just a standard constant volume rooftop, we probably wouldn't do that. Emergency contact, that just shuts the rooftop down. Maybe it could be a freeze stat, it could be a smoke detector, whatever it is. If this contact goes open, it shuts the rooftop down. Most likely on a standard rooftop, it would be like a smoke detector. And yeah, you could wire the smoke detector directly to the unit, and probably the right thing to do is run it through a relay and wire it directly to the unit, plus bring it up into the controller so that from down at the main computer you can see if the smoke detector is in alarm or not. So we'll add that guy there. So there's all the inputs we decided to put on our controller. And along with inputs, every rooftop unit's got to have some outputs. So what are the things that a rooftop has to turn on? Actuator. Well, I didn't give you guys enough information. So one thing that we have to turn on and off in a rooftop unit is the fan. So here's the fan. It's a digital output. That's really the only choice. It acts like it's going to give you another option, but a fan is either on or off. That's at least the fan state is. If you had a variable speed fan, we'll be able to see that later. But for now, we got the fan. What else do you have to turn on and off in a rooftop unit? Compressors. So we'll put cooling stage 1 there, and we'll put on cooling stage 2 there. And what else? Heating stage 1, gas valve, same thing, yep. So this is our standard. We've just developed a standard 2-stage heat, 2-stage cool rooftop. But let's say we do want to control the outside air damper. Most rooftops today it's built in, but again, this thing they call it a rooftop controller, but it does a great job of controlling small air handlers, even with chill water and hot water. It'll handle the modulated valves and everything else. But for our sake, we'll just go ahead and act like we're going to hook an outside air damper to it. Fresh air damper modulating. And just because we can, we got one more thing we could turn on and off. Let's see if we can find something interesting for our unit to control. We'll add a humidifier to it. Now, that's all really good. If we look back, we've got a space humidity sensor, but we're talking about controlling the economizer, and we really didn't stick an outside air temperature sensor on it. We're not really sure what how to control the economizer without an outside air temperature sensor. So I'm going to find an outside air temperature sensor. Outside air temperature. And I don't know if you noticed, but you could have picked outside air humidity. This thing can calculate enthalpy. It can calculate indoor and outdoor enthalpy and look at the difference between them. But we're just going to go simple. So we've got an outside air temperature and to do our economizer, and we got a humidity sensor to do our humidifier. So now all this kind of makes sense. So we got the inputs and the outputs. Let's look at this heating cooling thing real quick. Since we didn't pick a set point for our room sensor, we're going to have to change the set points from this. We're actually setting this up in a little it's called LNS-based program. You could, if you have one of these guys connected, you can actually do all of this through here without having to buy any real software. There's a little wizard thing you throw on your computer to do this, but it's all free and everything else. So you'll see what this thing generates here in a minute. It'll actually generate a picture for us to use to check the unit out. But here's the occupied heating, occupied and bypass. Occupied is obviously when the unit's occupied. Bypass is when somebody comes over here and hits this little override button and the thing runs for an extra 2 hours or whatever you decide. So we're going to say the heating is at 71 degrees. And the cooling we'll set at 73 degrees. And standby, if this would be like for a school. So occupied is when the kids are all there. Standby is what happens when all the kids and teachers leave, but the custodians are still there. They're not quite as nice to them. They're only going to keep it 65 degrees. And they're going to let the temperature go clear to 76 degrees in the summertime. Then eventually, the custodians finish their job and they go home. The temperature drops to 60 degrees or goes clear up to 80 degrees. And then we got a couple of things we can set up here that can be helpful. We've got a maximum supply air temperature. I'm going to say this is a gas rooftop, so I'm going to let it climb clear to 120. If it was an electric rooftop, maybe you'd want to stop it from going that high. It's just a safety thing. And a minimum, we're not going to let the discharge go below 50. Typically, that would be plenty cold enough, but we know the teachers in the school like to drop the temperature down to 69 degrees, and the fillers get a little dirty, and the discharge, we'll say it can go to 48 degrees before it cycles the compressor off. You think, well, that's not all that great, but that's something a normal thermostat can't do. It can't cycle the compressors off if it starts to ice up. Minimum time in heating. If we go into heating mode, we're gonna stay in the heating mode for 5 minutes. Mechanical. Here's a minimum on-off times for your compressors, and here's a minimum outside air temperature for your mechanical cooling. So we're going to let the mechanical cooling run to 55 degrees if it wants to. If it ever gets colder than that, even if the economizer can't keep up, we're going to lock the compressors out. You could drop that as low as you want. It's not a big deal. Changeover delay. That means if somebody is playing with the thermostat and you're in heating mode and all of a sudden they flip it real cold and take it over to the cooling mode, it's going to wait there for 5 minutes before it swaps. That way, if somebody's banging it back and forth, it's not sitting there heat, cool, and going crazy. The economizer, we're going to let the economizer run any time it's below 60 degrees outside. And if we would have put outside air temperature and humidity on it, it would have calculated enthalpy and said if we are less than 7.67 BTUs per pound of air, we're going to let the economizer run. We didn't add an outside air humidity sensor, so it can't calculate enthalpy, so it'll ignore that. We got some fan and valves here. This, if we selected a different type, but if this guy here can actually read current in amps, so if we just set it up for, we want to declare the fan on when this thing hits 1 amp. So you could actually pull the belt off, measure the current, say, oh, we've only got a half amp without the belt on, and we got an amp, and we got a full amp with the belt on. You could actually use this guy to tell if the belt had been thrown or not. The current sensor we selected in the setup was just an on-off. It's either there or it's not. So this wouldn't actually apply. If you were doing a variable speed fan on a VFD or something, and you don't want the fan speed to drop below 30%, you could apply that here. Once the fan shuts off, it stays off for 2 minutes. This is only if you have valves on your system, a chill water valve, a hot water valve. It doesn't apply to us. It's grayed out. PID, that stands for proportional integral derivative. They're all set. You don't have to mess with them. There is math that goes on behind it. You could actually calculate all of these things. To be honest with you, I don't know how to do it. If for some reason we did have to change one, to be honest with you, all I'd do is, if things were hunting up and down, I'd increase the integral time, and things would probably stabilize right off the bat. I might take 2 or 3 guesses, and we'd stabilize it. The only one I've ever had to change is if you have a fan with a VFD on it. I think I have played with a couple of these numbers to get the fan to stabilize, but generally you don't have to do that. Alarms. This thing will auto-generate some alarms if the space temperature is more than 10 degrees below set point for 1800 seconds, but you can change it to whatever you want it to be. The nice thing about this is if it goes unoccupied and it goes down to 60 degrees, it's going to throw an alarm when it hits 50 degrees for 1800 seconds. So it's not going to generate any nuisance alarms. They should all be real. If you don't have the sensor like duct pressure, we don't have a duct pressure sensor, it'll ignore the alarm if there's no sensor there for it. So you can have it auto-generate some alarms if you'd like. Some general settings. Here's for your fresh air. Let's say you want 10% minimum fresh air. And I don't know why you wouldn't want it to go to 100%, but let's say there was a reason you never wanted the damper to go over 75% of the way open. Oops. You could limit how far it goes open. Dampers, most damper actuators are 0 to 10 volts. But they also make them in what we call floating point, which means you power to drive one way, you power to drive the other, and it knows where it is based on time. And so, like this valve here is not floating, But if it was floating, it has a drive time of probably 90 seconds, but I don't see it written on there. So it keeps track of how long it told it to drive open, how long it told it to drive closed, and from that information it can tell where it's at. So if you were using a floating point actuator, which is really inexpensive, it would keep track of this. Let's say it was a standard 90-second actuator. You put in 90 seconds there and you're good to go. If you did have a mixed air temperature sensor, and you don't want the mixed air to drop below 60 degrees or whatever, typically we would probably set this at 50 degrees because the mixed air, it takes the average, and our free stat, it's going to trip off if any 1-inch section of it drops below 38 degrees. So as long as we keep the mixed air average at 50, we're probably not in much danger of tripping the free stat. This next one about terminal load and the outside air temperature, this thing calculates its requirement for heating and cooling, and if you want the economizer to be in that equation, you can have it in the equation or not. You mostly don't care about that. If you're trying to look at the whole building as a whole and calculate how much heating and cooling you were using as a percentage, that might be an important thing to you. It's not generally something we care about. Here's the humidifier information. Right now, when we drop below 40% relative humidity, we're going to turn on the humidifier, and it's going to stay on or off for a minimum of 3 minutes. We put a CO2 sensor in there, so when we go over 1,000 parts per million, if that happens, we're going to start to open the outside air damper a little more than the 10% that we set. We picked the thermostat with an override button. The override button, it actually shorts out the temperature sensor. That's all it does. But when this controller sees its temperature sensor gets shorted for 3 seconds, it says, oh, somebody pushed the button. And if it was in the unoccupied mode, generally I'd set that for 120 minutes, the unit would come back on and run in the occupied mode for 2 hours, or whatever you set that at. So nice little function. You don't have to, if the teacher wants to come into a classroom and start her equipment back up on a Saturday morning, all she has to do is hit the button and she would be allowed to do that. Or if the school system said, you know what, we're not paying to heat this building on Saturdays, she can hit it all she wants now. Options. It has optimal start-stop. So it looks at what time it's going to go occupied, and if it were me, I'd set that at 240 minutes. That means if it needed to, it could start up at 240 minutes before the scheduled time to make sure we hit set point right on time. And I'd tell it to do that in both heating and cooling modes. If the start time is 7 o'clock in the morning and you don't want it to ever start more than an hour early, there you go. It'll never start more than an hour early. Frost protection, that just says if some crazy person comes in and sets the thermostat at 20 degrees, it isn't going to matter. When it hits 38 degrees, it's bringing the equipment back on regardless of what the set point is. It's just to keep an operator from screwing up too bad. This terminal load, because this unit can also be used for a VAV system, it can do some calculations to help you decide what to do with the, whether we're going to bring on the equipment if a VAV box thermostat button gets hit. So because it's LON, it can share data between pieces of equipment. If you tell it that, hey, all these VAV boxes have buttons and I want them to be able to bring the equipment back on, you could check that box, and then any VAV box hitting their button would not only start their VAV box, it would also start the rooftop unit as well. We're not going to spend much time here, but those same VAV boxes can give their demand request to the rooftop unit so it knows how to stage on the compressors. And if some of them are calling for heating and some of them are calling for cooling, it's all preset, but basically the way they set it, cooling wins over heating every time. And if you need something special, you can tweak these numbers, or you can actually do a little program inside your tritium panel to compensate for that. But generally it just works pretty well right out of the box. That's also based on what the VAV boxes are doing. If you're doing it with VAV, we're not. An NVI is a network variable input. This is information coming into the controller from other controllers. And if you want to send that, how often does it go out and look for it? If I want to know, let's say there was a VAV box that had a CO2 sensor on it, and I wanted to get that information every 20 seconds, that would force it to go out and look every 20 seconds for that information. If you were sharing a lot of data between controllers. In our scenario, it's just a simple rooftop. It doesn't matter. Output, that's information coming out of our controllers if we're going to share it with somebody else. And if there was a problem with one of the temperature sensors, it would tell us here, we're not actually wired to it, it's not going to work. Finally, we can put in a name of the unit and call it whatever we want. And if we hit apply, it'll save all the information. And this little startup program that we use is really nice. So we programmed this rooftop unit. Now we're wondering if it's really working or not. So there's two parts to this. There's one part is the configuration. Find the one that we're doing here. Let's see. Yeah. And if I want to see what the unit's doing, if I look at this, we call monitoring, it takes all the information that we just put into the controller and draws us a pretty picture. Now the controller's not really there, so it's not going to have real live data on it. Hopefully it's going to open up here in a second. There it goes. So it drew our rooftop unit. Here's our humidifier. Again, if this was live, they wouldn't have question marks. It would be information. We put a humidifier on it. It would tell us if it's on or off. Here's our supplier temperature sensor we stuck in it. We put a fan current sensing donut on here. We put a CO2 sensor on it. We have an outside air damper. We have 2 stages of cooling, 2 stages of heat. All of our set points would be here. It would show us the room temperature, the cooling, the heating set point, the humidity set point, the outside air temperature sensor. And all of these things all came together in a nice, simple way for us to look at and check out. This is why we like configurable controllers. Honestly, if I'd known what we were going to do with this and how we were going to use it and didn't have to talk through it, we could probably set up one of these controllers in less than 1 minute. And a minute later, we have a full-blown graphic of how the unit's operating. We can check it out, check all of our sensors, make sure equipment's coming on and off. Configurable controllers are great for that. And the VAV box is very, very similar. The heat pump, fan coils, all have the same basic functionality for that piece of equipment. And then the other type of controllers that we talked about are called programmable controllers. They can do whatever you want, and we're not going to spend a lot of time. If I were to write a program from scratch for a rooftop unit today, it would probably take me 20 minutes. So we don't ever write anything from scratch. If I'm getting ready to do a rooftop and I haven't done one lately, I didn't save one in my system, I would go to one of my other guys and say, hey, do you got a standard rooftop? And they would say, sure, and they'd give me the file for it, and I'd load it in here, and it'd be 85% of the way done, and I'd tweak it out the way I want, and then I'm going to spend about 5 minutes setting it up. But if we were going to do a very sophisticated chilled water plant with primary and secondary pumps and cooling towers and variable speed drives on the fans on the cooling towers and plate and frame heat exchangers and isolation valves, we might spend 4 hours putting it together and maybe another 2 hours debugging it. So if we were going to do a chilled water plant, a big chilled water plant, I'd probably set aside 3 days to pull it all together, programming it, testing it, not installing it, but writing the program and testing it and make sure all the sensors work. You know, you got 5 sensors in the building or 5 sensors on the system and it's not run yet, and you look at it on your screen and they're all 78 degrees. Well, how do you know the electrician ran to the right spot? Well, you get your buddy and you go and say, well, go to the chill water supply temperature, and he unwires it and you watch it fail. And so you can wrap up 3 days in a simple chill water plant if you wanted to. But we're going to do just a couple of quick things just so you get a feel for how the programming works. These are little blocks over here, and they're all, you learn what's inside of what. But the first thing I'm going to do is get a set point. And a set point's a constant. It's something an operator changes. And it's a numeric value. It's a numeric thing. So I grabbed what they call the numeric constant. And the first thing I'm going to do is rename it set point. And then I'm going to set it at 72 degrees. Now I've got a set point set at 72 degrees. Well, we've got to do something with that. So I'm going to come down here to this little HVAC thing, and I'm going to grab a thermostat. So there's my thermostat. And since I'm going to turn something on and off, I probably need an input. Close that guy up a second. And inputs and outputs. So I'm going to grab a hardware input. And I'm going to name it room temp. Maybe. Uh-oh. That didn't look good. It just gave up on me. Let's try that again. Actually, let's see here. Is it over here? I think it's this guy. Come on. There it is. I guess that was not it. That's okay. I'll just so you can have all these different pages of control. I'm just going to add us a fresh page to this one. I guess I picked the wrong one. Add a page. So there we are. So I'm going to start over again here real quick. I'll grab an input. It's a hardwired input. Whatever's going on, it doesn't like that at all. One more try. Complete failure. I don't have a big enough screen to get back to my desktop. All right, one last try before oh, I could have done that. Let's try this. Sure. Oh, I'm sorry. Let's do, where did test go? Probably doesn't matter. Let's do this.
Should we call it control center?
We might have to. LNS. Local. That looks good. I don't know what's going on. I may have to get fired here. Huh. That is strange. Come on. See how simple this is?
I like the configure more.
It did go a little better, didn't it? One more try. Hardware input. Let it run through. It was only a problem when I named it. Cancel.
It's probably Microsoft's problem.
I'm sure it is.
Joe, we're a little bit after our scheduled end time.
Okay. Okay, real quickly then I apologize. I don't know what the deal was there, but let's go. One of the things I wanted to talk about, and we'll get everybody out of here if they want to go, that's fine. We can go live to a building after this. But one of the things I wanted to close with was where is DDC Controls going? Where we see it going with both Distech and several other vendors is that it's going to be BACnet, but it's going to be over IP. It's going to be, we talked about maybe wireless wasn't the best solution, but what we're seeing is all of these controllers shortly, hopefully by almost all brands, are going to go on the same wireless network that my laptop's running on. It's the owner's IP network, and since it's BACnet over IP, it can run on the same infrastructure. And the new generation of Distech controllers, not only are they BACnet over IP, they're also their own little Wi-Fi hotspot. So when you have a VAV box, the new generation of VAV box, which is out today, we haven't embraced it yet. But if you want to wire it BACnet, just the same way you'd wire this one BACnet or LON, you just plug in a little Wi-Fi device, and it has its own built-in graphic right in it. So using your cell phone, you can walk underneath that device. If you know the IP address of that device, it generates a graphic of this device and all the setup parameters right over your phone. You don't even have to go to a computer. You don't have to carry a laptop anymore. And I know that Distech's doing it. I know that KMC is doing it. I believe that Johnson Control will be out with it shortly. So it does a lot of things for a technician. As long as he understands how it works, and then he's got his phone with him, he doesn't have to have any software. You just walk up to it. Maybe you have to climb up, get the IP address. You hit that IP address on your phone, boom. You have full access to the device, full color graphics, all this configuration set up. It's all live. And since that device is running BACnet over IP, it's actually got its own little repeater. It starts to build a mesh network with other devices. It could be another control device. It could be the building owner's wireless repeater. And if you've got an area that with 10 VAV boxes that are up above the ceiling and they're all communicating over this BACnet IP network, and you have to get to the other end of the building and it's a long, long run, it's okay. You hook the BACnet wire back up and run it across the building. So it's going to be fast, it's going to be simple, it's going to be easier than ever to use. It's going to run over your cell phone, and it's going to be part of what we're going to call the Internet of Everything. For years they've been talking about the Internet of Things, where maybe refrigerators on it. But we really believe that in the next 5 years, every new thing that comes out is going to be part of the Internet. It'll have an IP address. It'll have built-in web devices that allow you to access it just through a graphical interface, and all of this stuff will get. It'll feel more like you're surfing the web at home than it is that you're feeling like you're working on an HVAC equipment. So we really see that going to be the way things are. It really is going to get easier and easier, even if my software wouldn't start. Hopefully that won't be an issue very often. But that's really the way things are going. Everything will be every piece of equipment will be directly on the Internet. And hopefully that will improve the cost, because there's no wiring. It's running over the same high-speed backbone that's in your building already, and you're welcome to to share that between HVAC equipment, PCs, your cell phone, your tablet. It's all there for you to use it just like you're part of the Internet. So that kind of brings us to the end because we ran out of time. If you'd like to stay around, we can call up a job. If you need to get out because it's late, that's fine. If you'd like to have some more food, that's fine. If you've got questions, that's great. Any questions? Well, I'm going to go ahead and call up a job. We'll go live to a project in Long Beach, California. Okay, you want to read it?
Yeah. If we have the small screen controller you mentioned, we could use Wizard software to look at it remotely as well as locally. Will you mention where the software is available?
Okay, so the question was, if you have this controller with a small screen on it, can you look at it remotely? The answer is not really. I'm not 100% sure what they meant by remotely. I guess if you run a wire to it and run it to your laptop, you could see it remotely. But if you really want to see what's inside this controller remotely, it really has to either talk LON or BACnet down to a tritium panel, and the tritium panel is where the graphic for this guy is held today. Not in the future. In the future, the graphic will be held right here. So you will be able to look at it remotely over its IP address. But today, for the most part, this device here is not BACnet over IP, so it talks BACnet to the tritium panel, and the tritium panel holds the graphic and puts it out over the Internet so that we can all see it. So in general, you cannot see this screen remotely. The other question I think they asked was, where can you get the program to program these? You get a couple of choices. We'd hope that you would tie it to a tritium panel, and then if you do that, all you need is the little plug-in. It'll run over the Internet through your tritium box and then down to your controller to reprogram it. The software to do that is free. If somebody wants that software, they can give me a call. My cell phone number is area code 317-919-8571. And if you have a tritium-based system, that software will run right straight through tritium. If you're not going to do it through tritium, you would have to have a little USB adapter. There is a free version of the software to do it not through tritium, but that's got some extra challenges in it. So for the most part, if you want to use the free version of the configuration software, it's typically done through tritium. But again, if you have any questions I can answer directly, you're welcome to call my cell phone, and I'd be more than happy to walk through the details.
When you're saying not using the tritium and you plug directly with an adapter directly into the laptop, you're not going to see the graphics though?
No.
You're just going to see some...
Well, there's two parts to that. If this is a custom control, if it's controlling a chilled water plant, there's no way it could be smart enough to generate the graphics for a chilled water plant. Every chilled water plant on a plant is different. On the other hand, if you're doing a configurable controller, you know, how many different configurations for a VAV box are there? Fan powered, non-fan powered, series parallel, hot water, electric heat, whatever. It's smart enough to handle that. So if you're using a little inexpensive program, then that's what auto-generated that graphic for the rooftop. So it really depends on how you're going to do it. If you're not going to have a Tritium front end, you can use the software, and you can see the graphics for the configurable stuff. Programmable stuff, there's no auto generation of graphics. It's just there's too many possibilities for.
Somebody'd have to generate that.
Right, somebody'd have to generate like the little project we're going to be doing together. No one would ever think that they have to build a graphic for what we're getting ready to do. I've never heard of it before. I think it's going to work really well, but you just wouldn't think of a graphic for that. So it really depends on how you're going to do it. Let me close a handful of things here. Hopefully I didn't just close the wrong thing again. Okay, so what I'm going to do is we could go look at this project we're going to go look at through Internet Explorer, but I'm going to cheat. I'm going to do it through my Tritium software, only because it remembers all my IP addresses for me and remembers my login and password for me, and so these are all the different versions of Tritium that we've used over the last 13 years. So I picked the latest version of Tritium, which is where my technician developed the project at. And I'm just going to go find it in the list. And it's called Meeker Baker. And all I'm going to do is click on this guy. It's going to remember the IP address. And it remembered my password. It didn't display it, but it remembered it. I'm just going to hit the home button, and I'm going to slide this guy out of the way. We're looking at if this was on a widescreen monitor, it would. Did I kill you again? I'm going to say that's why I couldn't launch that software earlier.
Think so?
Yeah. So this was developed for a widescreen monitor, but our little projector up there won't do widescreen, so I'll have to move the things around a little bit. I'm about to run out of battery, so we'll have to hurry up. So hopefully if we did our job, anyone can operate this building with little to no help. So we got a couple of buttons we can look at. Let's just go look at a floor plan. Again, I'm doing it on a small graphic. Let's just go pick the first floor. There's the first floor. We took the AutoCAD drawings that the engineer drew, and it'd be nice if you could see it all in one shot. But you can see the whole building, or at least the whole floor there, pretty much in one shot. If you want to see what's going on with this heat pump, click that guy there, and give it just a second, and it populates. So we can see here that we got a space temperature of 73.8. We've got a 75-degree cooling set point. Oh, that's the limits for their thermostat. Here's some unoccupied set points. Let's see what we got here. The thermostat is actually set at 72 degrees. They've only got a 1 degree dead band between heating and cooling. That's not very much. But we're pumping out 49-degree air. That ought to be cooling the space. So we might have a customer that calls and says, my space temperature is almost 74 degrees. It's unbearable in here. But what we can see here is that the heat pump's doing a great job. It's pumping out 49-degree air. Can't complain about that. We can see the fans running. We can see the isolation valve is open. If that space is warm, it's probably not due to that heat pump.
Is there any sensors that measure pressure, refrigeration pressure?
Sure, absolutely. If you wanted to throw a couple extra pressure transducers on this thing, you absolutely could. In this case, this building has 100 and some heat pumps in it. We used the really small controller to do this. We'd had to probably go to a more expensive controller. They'd have had some extra wiring. They'd had to buy the sensors. It might have cost $300 a unit to do it, so that's why they typically don't. And it all goes low bid. So we can go back to home. All the floors look about the same, but we'll jump out and see the cooling tower. This is a heat pump system, so again, I wish we had a little bit bigger screen there, but we can see the tower water going out. We can see if the fans are running. We can see our pump statuses. We got this guy on, this guy off. This is pumping out to the towers. These two pumps are pumping down to the heat pumps. We got a differential pressure transducer, and we're controlling the speed of the pump to maintain 4.3 pounds of differential pressure across the loop, so we got enough water flowing through the heat pumps. Go back home. We've got a couple of energy recovery ventilators. Since the heat pumps don't have any outside air on them, we got a couple of these guys. We're blowing in outside air and then blowing the exhaust back out, pulling it out of the restrooms actually. So it's all relatively low cost to bring this air in because we're preheating it or pre-cooling it by the exhaust air. We can see the fan statuses, both of the supply and the return fans, supply and exhaust fans. Real simple little units. We can see the heat wheel turning on it. Again, real easy, but nice to know that the equipment's working. Schedules are really easy in this building, on this system. Looks like they broke the schedules up by floor. We'll just look at the first floor schedule. The green part's the occupied time of day. Starts at 6 a.m. and runs till 7:30 p.m. Except for on Fridays. It starts at 6:30 a.m. and runs till 11 p.m. It's unoccupied all day on Sunday. It looks like it's occupied a little bit on Saturday. If you want to change one of these, just grab the edge of it, scroll it up or down. Or you could come over here and type the numbers. See that it changed that. I'm going to exit out of this without saving. Again, this was laid out for a widescreen monitor, and our projector's kind of limited. It's going to ask me if I want to save it. I don't. It also does trends. It can remember anything you ask it to remember. It can remember. You do have to ask it. I'll just take the space temperature of this heat pump. We'll drag him over there, and I want to see it for the last 7 days. And I tell it to build me a chart. And there it is. Looks like it went crazy, but it's not as crazy as it looks. It only went as high as 75 degrees, and it did that at 2 p.m. Went to 75.9 degrees, and it's gone as low as 71 degrees. And if we want to zoom in and see what's going on, we want to see what's going on right here. We just take this, zoom in, there it is. Or if you want to see that section, you can keep zooming in as much as you want. So anything you ask it to remember, it will, and you can retrieve that depending on how long you ask it to save it. And finally, we'll look at alarms. Hopefully there aren't any. It'll actually probably have a couple of things we call ping failures. Nope. So I've got a couple of space temperature alarms. Actually, it shows where it returned to normal. Everything's in green. At some point in time, that must have gone into alarm. Looks like the supply temperature to the heat pumps had gone out of whack at one point in time, has now come back to normal. So, and normally those alarms would stay there. Somebody must have acknowledged them. These are set to call out to the maintenance facility at night if they want to. So hopefully, if we do a good job, the systems are easy to operate with just a very little training. Let's do one other thing here. This is a list of all the different jobs. Now we're actually diving down inside of a job. Let's see what happens if I try to do this. Here's the wizard. It didn't open earlier. Hopefully it'll open this time. And like I said, I'm doing this in Tritium software, but it would all be identical in Internet Explorer. Maybe.
Look down at the bottom there, it's something open at the bottom.
Did it?
That thing,
That one says Mika Rig. There we go. So this is the actual programming. If we look at compressor control, here we go. Let's just see what he's got in here. So he's got the active set point. Yeah, this is relatively, I didn't want to go through all that. Let's see if we got a, yeah, I was hoping for something super simple, but what he's actually doing here is he's determining at what temperature things turn on and off at. So this actually says active cooling set point if it were strung out a little bit more. So this defines that at a ½ degree over set point it turns on and a ½ degree under set point it shuts off. So it's just doing the math to find a ½ degree above and below that. And it comes over here and it takes that math and it calls it cooling compressor off point and cooling compressor on set point. Although I think he actually misnamed them. Didn't hurt anything. And it comes through here and this has what they call a smart sensor on it, which is a little LCD temperature sensor that looks like this, that's wired into it, and it's taking the data out of this. And so it says when the temperature gets to a ½ degree above, it turns it on, and when it gets a ½ degree below, it turns it off, and it sends a call out to the compressor. This is actually just a little more complicated than I wanted to get into, but this is typically what the programming looks like. As you can see, it's not all that bad. This is probably a little more complicated just because my son wrote it. He's really, really smart, but sometimes he doesn't look for the most simple way to do things. But anyway, here's the fan. It checks to see if it's occupied. Occupied is always 0. So if occupancy equals 0, or if it's calling for heat or calling for cooling, this what is he doing here? Oh, he's actually he's got it set up so that it can have an automatic fan or continuous fan. Again, a little more than I wanted to try to walk through. I guess it wasn't a good choice to look at as far as complexity. Not a good choice at all. But anyway, you can see that it's not an overwhelming thing. And if we were to walk through it, we'd spend a couple hours together going through what each one of these little blocks does. In just a relatively short time, you could learn to plug all these guys together. And I'm going to get out of this. I don't want to save anything that I did to it. But that gave us the ability to change programming in a controller that's in Long Beach, California via the internet. And we could have done it. We didn't. We used Distech Tritium software, but we could have done it without any software at all. So if anybody else has got any questions, we'd be more than happy to answer them. Sorry to keep you late. Sorry we didn't get a good example of a simple program.
So what's one of them, like a 16 input output controller cost?
If you get it with an LCD display on it, let's see. 16 in out, that would be a
Well,
six.
okay, is there a smaller one than this?
Oh yeah, this is the biggest one they make. And this one actually you can add extra I/O to, but with an LCD display, you can go down to 6 in and 8 out, and that's probably in the $400 price range, depending on how you get a couple of options. LCD display costs about $100. You can get it without the LCD display. You can get it with handoff auto switches.
Well, I was just curious. I thought I might get one just to mess around with it.
Yeah, if you were going to play with one, I'd get the smallest
Right,
one.
right.
Say if you got it with an LCD.
So what about when you start going into this tritium up front thing?
This thing cost me $3 grand. That's what it cost me. And here's the reality of it. I'm pretty decent at controls. I went to school for 40 straight hours on this, and it was intense. And the disc tech class, there's 2 disc tech classes. Actually, there's 3. There's one for configurable, one for programmable, and then there's one on design, laying out networks. So you could spend 3 weeks here, and a week. You could spend a month at class.
I'm just interested. So I've got a Alan Bradley. I did a program for. I did a job for Hoosier Energy, and we put some. We took a boiler. They had this old boiler. It's a 250 horsepower boiler, and they wanted to put a PLC on it. And well, the reason was the EPA was making them monitor their fuel usage through as a fuel oil boiler, and they used it to start this power plant. So they said, okay, here we got a slick 503 or 505. He said, here it is. Make this. I'm gonna give you a couple fuel oil meter. He said, well, I need to monitor this boiler and read the fuel oil usage on this boiler. So what they got to do, of course, you just talking about using 0.5. See, everything's 4 to 20.
Yeah.
That power plant's just miles of wire.
Yeah.
And then they won't let you use the thermistor either.
It's got to be an RTD.
It's got to be a thermocouple. Everything's got to be thermocouple.
I can't read a thermocouple, I don't think.
I had to buy a thermocouple. When I did the job, I ended up buying a thermocouple card to put in that thing. It was like $1,600 just to buy that card. But Hoosier's idea is, look, we don't trust thermistors, okay, to do what we do. So somebody have a question?
Yeah.
Oh, I'm sorry.
When you're ready.
Go ahead.
You have the main controller located downstairs with the VAV box. Controllers have to be connected together to one master per floor, and the rest of the VAV to be wireless.
If you were using the new style Wi-Fi BACnet, it can be any combination of that. The master controller, which would go in place of the Tritium panel, you can still use Tritium software, so it's still an open product, but it can go wireless to the first VAV box, and you could wire from there, or you could wire to the first VAV box and then go wireless. You could wire to one VAV box on each floor and then go wireless. It'll do any combination of wired and wireless that you'd like to do at any point in the system. So if you've got VAV boxes that are too far apart because of floors, you might wire that. So it's really just a matter of how you want to configure it and where you feel the strength of the Wi-Fi. And it's the same Wi-Fi that we use in a building today. That gives you an idea about its strength. You wouldn't want to go clear across the building from one device to another. If you were going clear across the building, I'd hardwire it. Just like you wouldn't want to try to use your laptop with a wireless access at the other end of the building. So it's got the same strength, same technologies.
What are some good resources to learn more?
Yeah, we can give you my email. My email address is Joe, J-O-E, at Jackson, Jackson, systems, systems.com, joe@jacksonsystems.com. I'll be more than happy. Probably the best thing to do is a telephone call to my cell phone at 317-919-8571. Again, that was 317-919-8571. We can talk about 8571. We can talk about what your needs are. It might be that the right thing to do is for us to help you. It might be that the right thing to do is see if there's an opening with Distech. Distech only puts one dealer in an area. If they had an opening, they might be willing to do it. There is some places in the United States you can buy Distech from wholesalers. If Distech is taken up, there are lots of other good companies. We really like the KMC company. We've been committed to Distech for a long time, but KMC makes a really good product that you'd be happy with as well, and lots of other good control companies. So I can help point you. I'd be happy to spend some time on the phone. Oh, great. Thank you.
Well, yeah, or give you a program that control. I'm gonna take it back to shop, and I'm gonna.
Thanks a lot, guys.
Thank you.
Everybody online.
Thank you, everyone online. If you have any questions, please give us a call or you can drop us an email.